The variable's a. You got 5a on the left and 4a on the right. Now the best strategy here is to move from the smaller to the larger. So you have to decide which is larger, which is smaller between 5a and 4a. And hopefully that's clear which one is smaller.
Or
4a, yeah. So when you move from the smaller, you could be adding or subtracting depending on the sign, but you want to do that. You do not always move left. Sometimes you just hear like move left. It's like, no, that's not the right strategy. Sometimes, it works a lot, but it's better to move the smaller to the larger. So you have -3 plus a equals -10. What would you do to solve this equation from here?
um
Look at the side with the variable. What's keeping a from being by itself?
1,
What is this number right here?
-3.
-3. That's what's keeping a from being by itself. So how do you
Okay.
undo this -3?
Add 3.
Add 3 to both sides. Now you said 1. Maybe you're referring to the 1 in front of the a. Is that possible?
Yeah.
Okay, and that's okay. That's like there's going to be that a there. -10 plus 3. What does that become?
-7.
-7. Good. Questions on that?
I don't think so.
Okay. All right, so let's look at another problem here. And if you ever need to get this down in your notes, I mean, you saw I sent them to you. Hey, Matthew, hold on, I want to get that down, or I will ask you to solve some at some point. Okay. So new
Okay.
question here, variables on both sides. 3n minus 5n, which is smaller, 3n or minus 5n?
3n.
So what I'm really asking on a number line, here is 5, here's -3. The smaller means more to the left.
Okay, so -5n.
Oops, and then boy, I'm sorry. Yeah, that's really bad. -5 and 3. Yes. Yes. So in this case, you want to move -5n left, and you do that by adding 5n to both sides.
Okay.
Okay. Now this is just your run-of-the-mill two-step equation. Okay. You look at the side with the variable. Side with the variable, -16 plus 8n equals -8. How do you
Okay, so
undo -16?
add 16.
Add 16. Yeah. This becomes 8n equals 8. How do you undo multiplication by 8?
Division.
Divide by 8. So you get practice with the two-step equations that we've been working on this whole time.
Okay.
All right. So far we've been moving left, but we don't always move left. We can move to the right, depending on the problem here. Let me see if I can find one that's kind of like these. Yeah, let me have you try these. One of these here. Okay. You ready to try one on your own here?
Sure.
All right. All right. So here's one for you to try. Go ahead and work it out. Let me know what you come up with, please.
Sorry, I'm redoing the problem because I got mixed up a bit.
Okay, take your time. Take your time. They're not in a hurry. It's better that you do it right. So.
I got x equals 12.
Very good. So I assume you subtracted 2x from both sides. X minus 5 or 1x minus 5 equals 7, and then you added 5 to both sides.
Mhm.
Good. Now tell me a little bit more about what it is that where you were like, I didn't do it right. Like, and I'm not no criticism. I'm just trying to like figure out, what you saw, what kind of things came to mind there.
Like when I got mixed up at first.
Yeah, just give me a little more feedback so that I can better understand.
Um, Sorry, I'm trying to see what I did.
It's okay. We'll do another one here. Um, and what I'm going to have you do, we'll do it differently. So instead of you working it out, you're going to tell me what to do each
Okay.
time. Okay, so tell me the first. Go ahead and look at the problem, or if you want, you can write it down. Tell me what you see.
So I would subtract 4 from 4x.
Subtract 4x from both sides. Okay, good.
Mhm.
Now tell me what to write in the line below.
3x minus 10 equals 5.
Good. Okay. Now what to do next?
I would add 10 to negative 10.
Good. Tell me what to write next.
3x equals 15.
Good.
And then I would have to divide 15 by 3.
Good. So x equals
5.
good. Okay. Great. Very good. All right. Now let me show you a couple of problems here. We've spent most of today moving left, moving the variables left. All right. So, but in this problem, 6 minus 4x equals 12 plus 2x. Minus 4x is smaller than 2x.
Okay.
Agree with that?
Yeah.
Okay, so that means we're going to move the minus 4x to the right by adding 4x to both sides. Okay, so the result here is 6 equals 12 plus 6x. And to solve this, you again always look at the side with the variable. Side with variables is over here on the right. 12 plus 6x. So you undo 12. How do you undo 12 in this case?
Subtract.
Subtract 12 from both sides. So on the left, it's negative 6 equals 6x. How do you undo 6x, or the 6 times x?
Division.
Yes. So you divide both sides by 6. And you have negative 1 equals x, which is correct, but it's awkward. I think just
Mhm.
spelling awkward is awkward. You want the variable on the left.
Mhm.
So it's not good enough to just say negative 1. You have to say x equals negative 1. You have to assign it a value there.
Okay.
Any questions on that?
No, I don't think so.
All right. All right. So the next problem we're going to look at, here, sometimes you see where the variables almost appear to be the same. Let me grab this question and put it right up in the front here. So it's 10 minus 5x equals 5x. Like this. 10x minus 5x minus 20. Now, these are not the same. Like one is negative, one is positive.
Mhm.
Okay. So
Yeah.
this is where you still have to decide which is smaller, minus 5x or 5x.
Minus 5x.
Yeah, so you're going to add 5x to both sides. So 10 equals 10x minus 20. And then why don't you try solving it from here? What would you do to solve this?
I would add 20 to both sides.
Good. So that becomes 30 equals 10x. And now
And
what would you do?
divide by 10.
Good. And tell me, how would you write your final answer here?
X equals 3.
X equals 3. Good. Okay. All right. So let me throw a couple of problems in front of you to do. Um, I don't want that one. That one doesn't have a nice answer. Okay. All right. Why don't you try this one on your own, please?
Okay. I got b equals 8.
Like that?
Yeah.
Okay, so let's add 4b to both sides. I'm not saying you're right or wrong. I'm just going to work it out in case you want to look at it later. Minus 12 equals 4 plus 2b. Subtract 4 from both sides. So negative 16 equals 2b. Do you want to make any changes to your answer?
So instead of 4 plus 2b, I did 4 minus 2b.
Okay, so you get minus 2b plus 4b. I'm not sure. Did you add 4b to both sides? I can't see what you've done.
Yeah, I did. I
Okay,
just
that's
below
okay.
that I did a
We're
minus.
just we're just working on problems. You gotta you know, signs are super important here. So the only change to your answer is that when you divide by 2, b equals -8 like that.
Mhm.
So that's the only difference. So do you need any sort of refresher on signs or adding, subtracting, reminder rules, anything like that?
I don't think so. Just
Okay, fair enough. If you do, let me know. We'll talk about how to do that. Okay, so the next thing here is let's have you try another problem here. Go ahead and see. Go ahead and try working that out, please.
I got x equals -7.
Okay, let's take a look here. So did you add 12x to both sides?
Yeah.
Okay, so we got 12 equals 6x plus 48. Let me know if that is similar to what you have.
Yeah, that's what I have.
Oh, good. Good. Okay, so now we're going to subtract 48 from both sides. What is 12 minus 48?
-36.
-36 equals 6x. Good. So everything so far is good except your answer. Like you're dividing by 6, maybe just you didn't quite remember exactly how that works, but it is negative. It is negative x, -6, sorry.
Oh, okay, yeah, I miscounted the sixes.
Right. Okay, so let's try another one more. Got to get you to do it, fully right, start to finish. Then we'll move on to some new types of problems, which really aren't new. They're just variations of what we've been doing, but nevertheless, they're part of this. So, all right, so go ahead and give this one a try. Please. Actually, this one does not work out nicely. That's not what I wanted, so we're not going to do this one. Okay, sorry. Here's one that does work out nicely. Are you doing the in your class? Do you know if you're doing the what's it called, the Saxon?
I'm not sure
Okay,
for the next school year.
all right, yeah, because the like they have more. I mean, they're it's different, but give this one a try here. Smaller numbers should be more doable.
I got x equals 3.
Yeah, let's take a look here. Subtracting x from both sides. Always let me know if there's anything different between what you see and what you've got written down, and then you add 6 to both sides. 9 equals 3x, and then divide by 3. So x equals 3. Now, I'm not sure if you're the type of student that it's not a good thing or bad thing if you are or not, but like sometimes students, I mean, I always wondered, well, what if I didn't do that? What if I moved the 4x over? Like, would it give me a different result? And what do you think? Like, what's your initial opinion on that? Do you think if you go the other way, if you'll get a different result?
Um,
Well, let's try it out. We'll try it out here. So 1x minus 4x is minus 3x plus 3 equals minus 6. Plus 3 on undo positive 3, subtract 3 from both sides. Minus 3x equals minus 9. And you divide both sides by minus 3. So x equals 3, which is the same.
yeah, that's the way I did it. Um,
Okay, but you don't want to do it that way. Like um you really want to move from the smaller to the larger. Like these are best practices. Do you know what I mean by that when I say best practice?
Yeah.
And I know it's different. It's not the same. It's like but if you don't do it that way, like you will run into problems later on. That's why this is recommended. And I'm trying to choose problems where it's reasonable to do. I know it's
Okay.
uncomfortable to move to the right, but the so if you always want to move left, here's another possibility or something for you to think about is if the smaller one's on the left, you can rewrite this where you just flip what's on the left and right.
Okay.
This is okay. It's not most efficient, but it is okay. It will definitely work, get you back to the right answer. Okay, so we're gonna move on to some new questions now. We now know how to tackle problems with variables on both sides. Uh, I think this is the one to do next. Sure, doesn't really matter. All right, so here's a new problem. It's got variables on both sides. 8x plus 6x equals 8x plus 4x plus 12. You want to combine like terms first. You remember last time we did some combining like terms. We also dealt with the distributive property. Do you remember doing that a little bit?
Yeah.
Okay. So like what is 8x plus 6x? What does that become?
14x,
Okay. And how about 8x plus 4x?
12x.
12x. Good. And now it's a problem like we've been doing for weeks. Well, not weeks. We worked it a couple weeks here. Like it's a two-step equation, but it's got variables on both sides. So your first step is to move the smaller to the larger. In this case, we are moving left, minus 12x, minus 12x. So it becomes 2x equals 12 and divide by 2, x equals 6.
Okay.
Any questions on that before I have you do one like that?
Um,
So you just combine like terms and then you solve. Well, let's do another one together. You can always say that. Say, hey, Matthew, I need more examples. I just don't get it. Or it's not clear. I'm happy to do that. Okay, so sometimes when you combine like terms, okay, the like terms are numbers. This is minus 7, minus 8.
okay.
So what is minus 7, minus 8?
Um, so that would be like, would that be negative 15?
Yes. And remember, this is now 1K, 1K, not 1,000, just 1K. So now it's like, okay, we got to move from the smaller to the larger. So which is smaller, the minus 2K or the 1K?
The minus 2k.
Yes. So we add 2K to both sides. What is left on the left? What goes on the left side of the equal sign when these cancel out?
This k.
0.
Oh, yeah.
Right. So in all the previous problems, when we added the variable like 12x minus 12x, we didn't put anything here. It was 0. 0 plus 12 is 12.
Okay.
All right. So this is 0 equals 3K minus 15. And you still look at the side with the variable. So what do you undo first? Addition, subtraction, or multiplication, division?
Addition, subtraction.
Great. So what do you undo here?
15, so add 15.
Add 15 to both sides. 15 equals 3K. Keep going. What do you do from here?
Divide
By
3.
Good. So K equals 5. Good. Okay. Let me throw a problem up here in front of you to try on your own. You can always ask questions. You can always say, hey, Matthew, I don't get it, or, what do I do next? I'm happy to answer questions, but yeah, why don't you hang on a second. Yeah, this one does work. This one does work out nicely. All right, so go ahead and try that. Let me know what you come up with.
Forgot R equals -4.
Sounds pretty good here. So it becomes 4R plus 13 equals minus 15 minus 3R. Add 3R to both sides. 7R plus 13 equals minus 15. Subtract 13 from both sides. And you get 7R equals minus 28. Divide by 7. R equals -4. Good. Really good on that. Me, so here you go. Here's one more to try before we move on to something new.
I got n equals -3.
Okay, so did you add these first over here?
Yeah.
Great. 3n minus 15 equals 8n. Subtract 3n from both sides. Minus 15 equals 5n. Divide by 5, and n equals -3. Really good. Really, really good. Do you feel like you've gained an understanding of this now that we've kind of worked through a bunch of problems like this?
Yeah.
Okay. The thing is, like, we can go into more complex examples, but it's the same process. Like, you're either going to be using the distributive property or you're going to be adding and subtracting like terms. I'm going to work out a few for you here so you can see that. But there's literally nothing new that I can show you at this point. So I'm going to just put up some problems in front of you and work them out. You can kind of just, see like what's going on. So these are your classic problems that you'll see on like entrance exams into colleges. If you do like a math placement test, they'll give you something like this because it tests all the skills that you need. So the first thing is to take that 4 and distribute that 4 to both here. So that's -12 minus 24x plus 6, 40 minus x equals. Then you combine like terms. So on the right side here, you can combine the -12 and the +6. And so the order doesn't matter, meaning like you can write -24x first, -6, or you can put the -6 minus 24x, it doesn't matter. But same thing as before, you have to figure out which side to move the variable to. Now, why doesn't this work out nicely? Oh, it does. I see. Okay. Like, why? That's not working. It does. You're going to add 24x to both sides. So 40 plus 23x equals -6. And then you subtract 40 from both sides. You get 23x equals -46. Divide by 23. X equals -2, like that. But hopefully you saw from the beginning here that really, like, even though this looked really complicated, once you distribute, it's just like problems you've been doing. You got to combine like terms.
Okay.
So, I mean, is this a difficult problem? I don't know. It's a lot of steps. I mean, you said you like baking, right? Uh, is it if you bake 1 dozen cookies? I mean, there's some amount of work. If it's if it's uh if it's 4 dozen cookies is just more of the same. So this time with the distributive property here, you're distributing -8 to both here. So that's a little bit different. You do distribute with the sign. Um, so this becomes, grab this here, 7x. Now -8 times -x becomes 8x. -8 times 7 is -56, like that.
Okay.
So this is 15x minus 56 equals -16 plus 7x. And now we're back down to a problem like we've been solving over and over again today. So why don't you jump in here and solve this? It does work out.
Okay. Okay, I got x equals 5.
Okay. And let's see here. Did you subtract 7x from both sides?
Yeah.
Okay, so that's 8x minus 56 equals minus 16. Add 56 to both sides. That's where you got the 40. 8x equals 40. And then, yeah, x equals 5. Good. Really good. Okay, let's look at one more problem. Here, same style of problem here. So again, you want to distribute first typically. So this 4 on the right here is going to get distributed in. Yeah, minus 8x plus 32 because 4 times minus 2 minus 4x, you're going to distribute that in. So it ends up being 4 times negative 2 is negative 8. And so from here, we're going to move the smaller to the larger. So we're going to add 16x to both sides. And that's 8x plus 32 equals negative 8. Subtract 32 from both sides. 8x equals minus 40. Divide by 8, divide by 8. X equals minus 5.
Okay.
So you're now ready to solve any type of equation, really. There's a couple of other little wrinkles, but for next time, I guess we're going to do some lessons next week as well, probably at the same time. I usually get students on the same schedule. Next time, we're going to move though to equations of lines. And we're going to probably first talk about slope. Maybe you've seen that before, but any questions or thoughts before we close out today?
I don't think so.